Welcome everyone. We have made it to our last lecture in this course. We're going to take a look at two important ways in which we can improve the code that we write. We call these algorithm-centric improvements and data-centric improvements or solutions. In addition, in this last lecture, we will leverage our understanding of Python and C to demystify something about Python lists. So let's get started with an example that we saw in our previous lecture. We had written this function. Now our friend has followed along with our code and has a comment. Our friend says this code is really slow. Imagine you had not just 3 words here, but hundreds of words that have different spellings, and perhaps you also wanted to include various other words that are common in American English, but we use different words in Indian English. For example, Americans tend to use fall for autumn, and Americans use elevator, whereas we call it a lift. So let us say this was in fact a very large list. So this code, given a word, would have to come here, compare it to this first word. Maybe that's not the word. Then we would come to the second word. Then we would come to the third word, and so on. And this is what our friend is saying. This code is really slow. So let us see if we can improve this particular code. So the first type of improvement we are going to try is algorithm-centric. So instead of having a linear chain of if, else if, else if, else if, else code, we will maintain 2 parallel arrays. So one of the arrays is going to contain the US spellings, and then we're going to have a parallel array which has the corresponding Indian spelling. Now we're going to make sure that the US spelling is sorted in lexicographic order, which is dictionary order. So analyze will come before color because A comes before C in the alphabet, right? So let us say we have our arrays. These are the indices up here. And what we can do now, since it is sorted lexicographically, when somebody gives us a word, we can use binary search instead of linear search. We can jump to the middle. Our strcmp function will tell us if that word is exactly what we're looking for, or if we should search to the left or to the right. And that will find us the index of that particular word in the array US. Now, using that index, we can look up the corresponding array ind to get the corresponding spelling, and this should be much faster. Of course, we have to make sure that this binary search returns some special value in case the word doesn't appear, in which case we have to remember to return essentially that same word back to the user. So this is an example of algorithm-centric thinking to try and look for improvements. Now often if you want to implement a better algorithm, you often need a better data structure. Now, can you think in this context of a better data structure? Well, we are dealing with the US version of a word and the corresponding Indian spelling. So we have key value pairs. And for key value pairs, there's a very natural data structure. We don't need to maintain parallel arrays, we just maintain a dictionary. In Python, of course, the syntax is a dictionary where the keys are strings and the values are strings. And this will give us a very simple algorithm. Given a word, look it up in the dictionary. Of course, if it doesn't appear in the dictionary, then we have to deal with it. So that is a little complication. But our algorithm in this case is trivial because the dictionary supports the key operation that we want. And this will be much faster. So if you really wanted to implement the code that we have been struggling with, you should implement it this way. Now, how do you implement a dictionary in C? It doesn't exist as a built-in type. You would have to either find somebody else's dictionary implementation or write your own. Or stick with Python. It has a built-in dictionary.